probability distribution X, the number of imperfections per 10 meters is in continuous rolls of uniform width is given below. Construct the cumulative distribution function of X. So cumulative distributions are generally denoted by the big letters. So little f would generally mean a probability distribution, whereas a big F would mean cumulative distribution, like here. So you have to look at, in the discrete distribution, you look at the values, and the first value for the cumulative distribution, which is a piecewise function, will always be less than the first integer here. So the first integer here we see in the X row is 0. So cumulative distribution will start with X less than 0. And at that point, no probability has appeared yet. So all of these three do have X less than 0. And the last one has to be X. Okay, so after X less than 0, the next one would be greater than or equal to 0 and less than 1. So now this one is out because this one doesn't start greater than or equal to 0, but it just says greater than 0. So this one is a candidate because it says greater than or equal to 0 and less than 1, because 1 is the next major point. This one says greater than or equal to 0, less than 2. So this one skips 1, so that one is out. So we already know it's B. So when X is less than 0, there is no probability here because the probabilities start at 0. So in cumulative, you just add on the probabilities that are there. So nothing for X less than 0. So at X is equal to 0, we pick up a probability. Remember, f of X, little f of X gives us the probabilities. So at X is equal to 0, we pick up a probability of 0.37. And then there is no other probability until we reach 1. At which point we gain 0.37. So as long as you are less than 1, the only probability you have picked is the one at X is equal to 0, which was 0.37. And then here we have X is equal to 1. At X is equal to 1, you also pick up the 0.37, another 0.37 from here. So this first 0.37 was the one that was picked at X is equal to 0. And now you pick up another 0.37. So you add that 0.37 to this 0.37. So 0.37 plus 0.37 is 0.74. And nothing else is picked until you reach 2. So this one is up to less than 2. So nothing more is picked. So then at X is equal to 2, you also pick up the 0.16. So you add on the 0.16 in the already accumulated probabilities. So 0.74 plus 0.16 would be 0.9. And similarly, you don't pick up anything until you reach 3. And when you are equal to 3, you also pick up 0.06. So add on 0.06 to 0.9. So you get 0.96. And then at, pick up nothing until you reach 4. And at 4, you also pick up 0.04. So you pick up 0.04 here. So 0.04 plus 0.96 is 1. And that's always the case. Cumulative distribution function will always have 0 in the beginning, and it will always have a 1 at the end, because the overall probability that you collect in any probability experiment is 1. Okay. All right, so let's try it in this one. First, you have to make the function. So you know it has to start less than 0, and the second one has to be greater than or equal to 0, less than 1. So this one is out because it's skipping the 1. This one is in. This one is out because it doesn't start greater than or equal to 0. It starts greater than 0. So, or we know it's B. So when x is less than 0, you haven't picked any probability yet. And then when x is equal to 0, you pick up 3/10. And then when x is equal to 1, you also pick up another 3/5. So 3/10 plus 3/5. So 3/10 is 0.3, 3/5 is 0.6, so it's 0.9. Let's see if it accepts 0.9 or not. And then at 2, you pick up another 1/10, which is 0.1. So 0.9 plus 0.1 is 1. Okay. And now, which of the following is equal to probability x is equal to 1? So at x is equal to 1, we can directly see that it's 0.6. But they want it in terms of the big F. So f of 1 gives us everything up to 1. So that's not true. So let's see. So strictly at x is equal to 1, it will be f of 1. So f of 1 gives us everything up to 1. But we don't want the 0. So you subtract f of 0 off, and that gives you just the 1 at 1. So basically, probability x is equal to 1 would be the accumulation up to 1 minus the accumulation up to 0. Because the accumulation up to 1 will also include the 0 part, but we don't want the 0, we just want 1. So you subtract off the accumulation up to 0. So in general, whenever you want probability at a particular point, you take the cumulative distribution up to that point minus the cumulative distribution up to the previous point. So for probability x is equal to 1, it would be f of 1 minus f of 0. Similarly, if you were calculating probability at x equal to 2, that would be f of 2 minus f of 1. Okay, so probability x is equal to 1, well, we already know, we can see it from here also, it's 3/5. Okay, now x greater than 0, less than equal to 2. Now, so actually, f of 2 gives you everything up to 2. It also includes 0, but we don't want the 0. So we want to subtract off the f of 0 part from it. So it would be this one, because f of 2 gives you everything up to 2, including 0, because 2 is also 0 is less than 2, so it includes 2 and everything less. But we don't want the 0 because they're saying greater than 0. So you subtract off the probability that you have up until 0, which is big F of 0. Okay, and now we know that's f of 2 minus f of 0, so you can look either from this column or you can look from here also. So you want, when they say greater than 0 and less than equal to 2, so you don't want the 0, you just want everything between 0 but bigger than 0 and less than or equal to 2. So that means 1 and 2. So you do 3/5 plus 1/10. And that would equal, so 3/5 is 0.6, 1/10 is 0.1, so that's 0.7. It should take this one as well. So when it's asking for a fraction, it usually takes decimal as long as the decimal doesn't involve any rounding. But if you are getting a fraction where you need to round off the decimal, then it will not take the decimal, then you just have to type the fraction. Okay,